Hi, and welcome to this section of the Advanced Calculus 2 tutor. And in this section, we're going to, it would be the integral of a to b of 1/2. Now, r is simply a function of theta, right? So it would be function of theta squared d theta. So this right here is the one you're going to be using. If you're given a function of theta which describes this boundary, okay, then all I have to do is integrate over the angles, the endpoints a to b, and you see what I'm doing. As I start here and I integrate over, I'm sweeping out this area here. I'm adding up everything under the curve here in the same way when you're doing your area under that curve here. So this is really the lion's share of what you need to know for this section. We're just going to solve some problems to show you how to apply it, okay? So let's do that right now. Let's say you have a function, r is equal to theta, okay? And the angles that you're going to be confined to is going to be between 0 and pi. Okay, so if I wanted to find, this is some arbitrary function of theta. It sweeps out at some curve here, okay? And I'm looking from 0 to pi. Theta is bound by those angles right there. And what you're doing is you're sweeping out that area and you're adding up all those little slivers of area, and it's giving you the answer pi cubed over 6. Okay, now the next problem is a little bit more challenging. If I were given the function r is equal to 2 cosine of theta, and the angles I'm bounding myself by are between 0 and pi over 6. So I have some function, r is a function of some theta. I'm only looking at the angles between 0 and pi over 6. Pi over 6 is roughly 30 degrees, so it's really small angles there. I literally put a little curly brace down here and say, okay, now I'm going to work with this one. Only this one. Integral 0 to pi by 6 of 1 d theta. Okay, what's that going to be equal to? Okay, that's going to be equal to, just integrating 1 is theta evaluated from 0 to pi by 6. Okay, and that's going to equal, plugging in the top value, pi by 6 minus plugging in the bottom value of 0. So that's going to equal pi by 6. This value here is only this first part, okay? I haven't done anything at all with the second part, and I like to do them separately because if you start trying to integrate everything at once, you're probably going to make a mistake somewhere, and it's just not as clear where that mistake came from. So I just like to do it this way. Now integrating this guy, I draw a little curly brace and say, okay, now I'm going to deal with him. The integral of 0 to pi by 6 of cosine 2 theta d theta. Now, you might have a table of integrals that you like to use that you know the answer to this guy right here, but if you don't, every single time I do one of these things, it'll be 0 to 2 pi, that goes all the way around the circle, of 1/2 times this function squared. 5 squared is 25 sine squared of theta d theta, okay? Sine squared of theta d theta, okay? So what I'm going to have in the end is I'm going to have 25 over 2 come out of the integral 0 to 2 pi of sine squared theta d theta. Same thing here as the last time. Either you have a table of integrals or just memorize that, which is going to be fairly unlikely. There are limits, 0 to 2 pi. So this is going to be 25 over 4 times 2 pi minus 0. Just the limits of integration plugged into here, okay? And that's going to equal 25 over 4, okay? And actually what it's going to equal, let's go ahead and make it simple on ourselves here. This guy is going to cancel with this, leaving me 2. So on the bottom it's going to be 25 over 2 times pi. That's what that one's going to be equal, 25 pi over 2. So that's part of it. That is the solution to this integral. Also, how would I do it? The length is equal to the integral from a to b, which are just these angles, okay? Square root r squared plus dr d theta squared d theta. Okay? So the next thing we need to do really to use this, we need to find dr d theta. Okay? What would that be equal to? We haven't even really talked about finding derivatives of these things too much yet, but it's basically what you would think. Dr d theta, taking the derivative of this, is equal to 5 times, what's the derivative of cosine? It's common, and I'm going to have cosine squared of theta plus sine squared of theta, and it's going to be d theta. Now, this is a product under a radical, so I can take the square root of that 25 and I can pull it out of the integral. So it's going to be 5 times the integral, 0 to 3 pi by 4. Now look at here. Cosine squared plus sine squared. That should look familiar to you, okay? That's always going to be equal to 1 because that's an identity. Cosine squared plus sine squared is 1. So what I'm going to have left under here is a square root, and take it one step at a time, and this is very analogous to what we've done before. It's very useful. You'll be using it, and I think with practice, you'll get the hang of it.